Hi, good afternoon. This is a quick video for those of you that missed Lab 5 due to snow today. Alright, so I'm in Blackboard here. I'm going to go into Lab 5 folder. There is a set of files in here. The first one is the document, the lab document that we have. In it is a step-by-step, let me put it in the regular format, the step-by-step for this lab that gives you the assembly instructions for this assembly that you're going to make. So all the steps are here, and then there is limited assembly instructions for 2 Lego assemblies that you're going to make. Here's the final Lego assembly, and then for the 3rd assembly, and here's the Lego assembly here. The deliverables for this are there's a template here. So if I click on the template, you will see it's almost just like last week. For each assembly that you make, you will create a 4-view representation of the assembly, and you will also enter the center of mass for that assembly. So for assembly 1, there are 2 orientations of the assembly. So you'll do it for orientation 1 and orientation 2, and then you'll do the same thing for the first Lego assembly and its center of mass, and the second Lego assembly and its center of mass. Going back to the folder, the Lab 5 folder, the other 2 files are zipped folders that contain the parts that you're going to need. So if I select one, it'll automatically download it into my downloads folder. While I'm using Chrome, that's the way I have it set up to do. And I'll do the Lab 5 parts. So I have 2 folders that were now into my downloads folder. What I can do now is go into my downloads folder. I see that there are 2 zipped folders here. To unzip those, to utilize these folders, you need to unzip them. So I'm going to right click, and in my version of Windows 11, I have the extract all. Typically, if you're running Windows 11, when you right click, you will get some window pop up that lets you extract all. I'm going to turn off the show extracted files when complete. I don't need to worry about that right now. I'll say extract. And this is now the extracted folder. I'll do the same thing for this Lego parts folder. I'll select extract, and we're say OK. So if I open up one of these folders, you'll see that it contains a bunch of parts. Same thing for the Lego folder. This one contains 3 parts. Okay, so now what I'll do is I'll jump into SolidWorks. For this quick example, I'm just going to use the Lego parts. I'm going to create a new assembly, and I'll click OK. And right away, SolidWorks always starts up with this begin assembly. I'm just going to cancel here and turn that off just for a couple quick things. First off, I want to come over here to the lower right hand side. I want to set my units to mm/second. For the Lego assemblies, you're going to want to be in mm/second. The other thing I want to point out is that you should have the Y up as being your orientation. So that should be the default orientation. Another thing I'm going to do just to show what's going on here is I'm going to click on the arrow next to the eyeball. I'm going to click the option to view planes, and the one next to it, the hide show primary plane. So I want to show the primary planes for this assembly. So this is my assembly. It has 3 planes, and they intersect at the origin. So now when I'm going to bring my first part in, what I want to do is make it that the origin of the part is coincident with the origin of the assembly. So I'm going to insert components. I'm going to browse to my downloads folder. Now I should actually move these folders to my MEC 1200 drive before I do that. So let me go ahead and do that. I didn't do that when I started, so I'm going to select both of these, move them out of my downloads folder, and I have a MEC 1200 folder on my OneDrive, so I'm going to put them there. I already have those folders there, so I'll just skip those files and just make sure that that's where I go now. So I'm going to go browse. I'm going to go to my MEC 1200 folder. There's the Lab 5 Lego parts, and I'm going to bring in my Lego plate. When I do this, you'll see that there's a configuration box here that would let me bring in any number of variations of this part. So I'm going to bring in a plate 2x8. I'll select open, and now as I move my mouse around without clicking, you'll see that the part can be placed essentially anywhere in the graphics area. Now, what if I look over here under where it says insert component, it says hit the OK button to insert a component at the origin. So that means if I select this check mark here or this check mark here, it will automatically place the part at the origin, and that's what I want. I want to say OK, and I want this part now to be at the origin, and you'll see that the part has a front plane, and that front plane is lined up with the front plane of the assembly. If I hover over where the origin of the assembly is, you can see it here, and if I then went over and hovered over or clicked on the origin of the part, you'll see that they are now coincident with each other. So that's what I want. All right, so what I'm going to do here is I'm going to go back up to my eyeball here. I'll turn off the primary planes, but I'll leave on the visibility of the planes themselves. So why didn't they turn off? They should have. There we go. They turned them off. All right, and I have all the planes turned on for this part. I'm just going to turn off the views for the top plane and the right plane. I won't really need those for what I'm doing. All right, so now I'm going to, and then the other thing I want you to note is that this part now has an F next to it that indicates that it is fixed, and down here in the lower right hand corner you can see that the part or the assembly now is considered to be fully defined. I'm going to insert another component. I'm going to bring in a Lego S-beam, and I'll make it 10 units long. I'll say OK. And you'll note that there's this little flyout menu here that I can use to rotate the part around in different rotations if I want to before I drop the part. So that's something that's nice to do. Also, if you bring a part in and you don't have it in the correct orientation that you wanted, you can always click on the beam or the part in the feature manager, and it brings up this triad that allows you to move the part around. So I can move it in X, Y, and Z, and I can also rotate the part around. So it gives me a lot of flexibility that way. If the part comes in and it's not the right part, say this wasn't beam 10, that's what you wanted. Sometimes SOLIDWORKS can be a little flaky. The one that you choose when you bring it in sometimes is not the one that shows up. So you can always change what it is by just clicking on it. It brings up the left click brings up a menu. The top menu allows you to choose whatever configuration you want. So I could select, say, the beam 14 and just click OK, and you'd see that the beam itself would change. All right, now to fully define this assembly, I need to mate this part. If I say I look at this from the front, this part has all degrees of freedom, and if I view it from the right hand side, again, it has all these degrees of freedom. So what I'm going to do is I'm going to go in the assembly tool, I'm going to click on mate, and I am going to select this face of the part of the beam and this face of the plate, and you'll see that SolidWorks will make these two, and the default mate is coincident. And if I view this now from this side, you can see that the part can move up and down and left and right. But if I view it from, say, the top, you can see that I can't move it up and down. I can only move it left and right. So that means I need two other mates to fully lock this down. So what I'm going to do is I'm going to select this face and this face, and SolidWorks makes those coincident. So now if I again change the view, you can see that I only have this up and down degree of freedom. So lastly, I can select the bottom face of the beam and the top face of the plate, make those again coincident, and down here in the lower right hand corner we can see that SolidWorks says that we're fully defined. Through all of this, the mate tool has remained active. I'm going to say OK to dismiss it, and and one other thing I want to point out is that as I'm doing this, I'm clicking my middle mouse button, the scroll wheel, so I'm clicking down to allow me to rotate, and I'm also zooming out as I do this. So this is a skill that you have to get adept at as you're doing the assembly, just to be able to manipulate and rotate your part. Alright, so I'm going to bring in another component, so I'm up here under Insert Component. I'll click on the Lego beam. I'll bring it in as beam 7. I'll click the Y to rotate it, and I'm just going to drop the part. Alright, so this one I'm going to use the mate, but in this time I'm actually going to pre-select the mate. I'm going to select a distance mate here. I'm going to set the distance to be 5 millimeters. Now when I select this face of the beam and I rotate it so that I can select this face of the other beam, SolidWorks will position them 5 millimeters from each other, so you can see that it selected the distance mate. Now there are two options for it to being which faces are set 5 millimeters apart. This is what this one would do, would be flip the mate alignment. So I could click this and you would see that it would rotate the part, so now these two faces are 5 millimeters apart, but that's not what I want. I want the faces to be this way. So there's two different ways that you can select those parts. So I'll say OK. Now what I want to do is select, I want to make this cylinder of the part be concentric now. So I'm not doing a coincident mate, a concentric mate with this cylinder of the beam. So I'll select this cylinder and this cylinder, and SolidWorks again chooses them as being concentric. So I'll say OK. So we have the distance mate, the concentric mate, and if I view it from this side, we can see that there is a degree of freedom, an angular degree of freedom. So what I'm going to do here is I'm going to pre-select the angle mate. I'll leave the angle as being 30 degrees, the default, and I'm going to select, and again you want to select faces, not edges, in the diagrams that you're going to be using for making these assemblies, you're going to get a view like this with an arrow that's pointing between, and it's going to look like between lines, but really the angle is going to be between this face and this face. So if I select this face here and this face here, SOLIDWORKS puts them at 30 degrees, but you say, like, what just happened there? Why did it flip it that way? Well, that's a SOLIDWORKS thing, right? Here's 30 degrees. So it is 30 degrees between these two parts, but that wasn't exactly what you were expecting. So over here underneath where the angle is, there's 4 options. You can flip the dimension. Again, we get 30 degrees, and there's flipping the mate alignment. So if you keep clicking till you get some combination of the flip dimension and flip the mate alignment, you'll eventually get to the angle that you're looking for. So it can be a little bit tricky, but you just have to try the 4 possibilities. Okay, so we look again, our thing is fully defined, and this should get you enough to get started with the assignment. I'm also going to make an additional 3 videos that walk you through the assemblies, just because you missed lab today. So those will be the other video links in this email that I've sent you.